So the first unit that we're going to start with is called quadratic in vertex form. Okay? Do you guys know what the word quadratic means, or what does it represent? Yeah, because you're thinking about quad as 4, right? Anyone? Quadratic actually represents 2 in this case. It's a power of 2. Okay? So any function, I'm just going to add a page here. So any function that has a degree 2, an exponent of 2, we call that quadratic. Okay? So even if I have so let's say if I have y equals 2x squared plus 3x minus 5, that's also called quadratic, okay? The reason why it's quadratic is because your highest exponent in the function is 2, okay? So that's degree or exponent or power 2, okay? So quadratic functions, what would be a good example of a quadratic function in real life? Something that you see when you're at the park, or when you're watching TV, or when you're doing something every day. Anything that you see that could be represented in quadratic. Actually, I should show you what quadratic is. How would a quadratic function look like if I'm going to graph it? Does anyone know? What shape would it have? So this would be a shape of a quadratic function. Okay, either going up, right, or opening down, or you can have a shape that opening up. Does anyone know what the name of this shape is? Parabola. Parabola. Okay, so the parabola shape, what we've talked about, or what you should know before, is that you have the linear functions, which is degree 1, which give you a straight line. But now we're moving to the quadratic, which has a totally different shape, and the shape is a parabola shape. Okay? And then we're going to talk about the different features of the parabola, which way does it open, how do we know which way it's going to open. We're going to talk about the maximum point, the minimum point, and all of the lovely features of it. Okay? I understand that you guys probably haven't seen it, or if you've seen it a long time ago. So I do go in detail, okay, about all of these things. Okay, so if you feel like you don't know what's going on right now, I will be explaining most of it again. Now, in real life, do you see anything, or when you're watching, or when you're walking the park, or whatever, when you're cooking at home, I don't know. Do you see anything that has this shape, or can give you this shape of a parabola? An egg has an oval shape, so if you, that would be, if you take part of it. A bridge. That's a good example, right there. What else? You guys watch sports, don't you? Football. When you throw the ball, what shape does it? How is it gonna go? Do you throw it like this, or do you throw it? But what path is it going to take? When you throw the ball, right? You're gonna throw the ball, which it's gonna go up, right, and then it's gonna go down. Does that look like a parabola to you? Okay. How about basketball? You guys watch the game yesterday? Right? Exciting game, right? When you're throwing a basketball, guess what? It's a parabola. Yeah, right? So bridges, football, basketball, right? All of these are examples of parabola shapes, okay? Even when you're looking at a fountain of water, right? If the fountain is, like, if you have the water fountain and the water is going up and then going back down, right? It's going to give you that parabola shape. Okay, so there's a lot of real life application of parabola. Okay, not only in math, but we see it. And it's not funny, but for me, it's just like when I'm watching any of these sports, I'm looking at the math. I'm looking at, oh, what kind of parabola is this? How is it going to go? I see it. This is what you know, when you watch these movies and they show you what's going on in the brain of the person, right? This is what, when I'm watching these sports, this is what's going on in my brain. Parabolas. All right. So the first thing we talked about is quadratic have a degree of 2, okay? Power of 2, that's the highest degree. Now, we're going to also talk about how is it going to look like. So we're going to look at the difference between linear, and we're going to look at the difference between quadratic, and how can we, by looking at the equation, by looking at the table, by looking at the graph, how can we differentiate between linear functions and quadratic functions? Okay, we're going to have to be able, by looking at it, I can tell you right away if it's linear, quadratic, or linear or quadratic, or neither. Okay, by looking at it, I can, at the graph, at the table of value, or at the equation. Okay, so that's what we're going to learn today. So if we look at the first question, so the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Okay, so this is the equation of your function. Can you tell me from this equation if this is linear or if this is quadratic? Linear because? So there's no degree on that x, right? There's no degree on that x, so that means that's degree 1. Okay, so if you look here, I told you quadratic has a degree of 2. Do you see a degree of 2 here? No. Okay, so that means this is a degree of 1. So from the equation, I can say this is linear because it's degree 1. Okay, so it's easy. Looking at the equation, you can tell right away. Now, I believe the table of value is the hardest one of them to be able to identify if it's linear or quadratic. So in order for you to be able to identify from the table of values if it's linear or quadratic, you have to do what's called first difference and second difference. We'll get to the first difference and second difference in a second. How do we fill out our table of values? So what happened is, I know that my equation is y equals 3x, right? So I'm going to have to assign values of x. So the values of x, I either give them to you or you're going to have to pick values. Okay? Usually the values that we pick for x, the smaller values, the better. Okay? We usually go couple in the negatives and then more in the positive, or we can do only positive. Okay? So you see here that I've given you the value of x as 0, 1, 2, 3, and 4. Okay? So these are the values. I gave you these values. I gave them to you. So in order to find your y values, you're just going to have to replace the x with the x value. So for the first one, I'm doing 3 times 0, right? Because x is 0. Do you guys understand that part? So 3 times 0 gives me 0. For the second one, I'm going to replace x with a 1, right? Because I'm telling you that for the second one, I want x to be 1. So if I replace x with 1, that's going to be 3 times 1, which is 3. Then I replace x with 2. 3 times 2 is 6. Then I replace x with 3. So 3 times 3 is 9. Okay? So you see I'm finding my y values by substituting the x value into my equation. Are we okay with that? So you see your y values now? They're 0, 3, 6, 9, and 12. Now, here is the important part. Eyes on me, please. So in order for me to be able to determine if it's linear or quadratic, I have to do what we call the first difference. Okay, what does the word difference mean? So difference in math, what does it mean? A subtraction, addition, multiplication, division. Subtraction, right? So that means I have to subtract the second y value minus the first y value. Okay? So let's look at this. If I'm looking at my table of value, where's my second y value? So I'm going to do 3 minus the first y value. Okay? So I do 3 minus 0. What does that give me? 3. Okay? So I do 3, take away 0, and that gives me 3. Now I have to go down one more point, and I'm going to have to do the y2 minus y1. So you're going to have to take the lower value and take it away from the value above it. Okay? So you do 6, take away 3. That gives you 3 again. Then you do 9, take away 6. What does that give you? 3. 12, take away 9. What does that give you? 3. Now, if you look at your first difference and the answer for all the first difference, what do you notice? They're all the same, right? It's constant. Okay? So this is a feature of linear function. Linear functions will always have first difference constant. Doesn't have to be 3. In this case, it's 3. But as long as the first difference is constant, then we know it's linear. Okay? If I figure out that the first difference is constant, okay, then I stop. I don't have to go to the second difference. Okay? So I stop right here. So just to recap, what I did here after I found my y values, I subtracted the second y value from the first, or the first from the second. So I did y2, take away y1, so on and so forth. Are we okay with this? Everyone is okay with this? All right. Now I need to graph it to see how it's going to look like on the graph. Okay? So I'm going to graph this. I'm going to need the points. So I'm going to need the x and the y value. So, if you look here, x, y. Okay? So each point is x, y. So 0, 0, 1, 3, 2, 6. Okay? So, what do you think I should go up by on the y-axis? Should I go up by 1 or by 2 or by 3? 3? Okay. Now, if you pick something for the y-axis, you have to stick with it. So on the x-axis, I went up by 1. On the y-axis, I went up by 3. My first point is 0, 0. Okay? So that's where the origin is. My second point is 1, 3. So my 1 is right here, and then 3 is right here. So that means my point is there. Okay? Anyone doesn't know how to locate point on the x and y? We're okay with that? Okay? Then we have 2, 6. 2, 6. So the next point is going to be right here. Then we have 3, 9. And we have 4, 12. So what do you notice about this line? It's a straight line. They're lining up, right? I can actually draw a straight line joining all these points, right? So it's a straight line. So, equation, degree 1. Table of value, first difference, line, the graph is a linear. Do we understand that? Okay. Let's look at an example. So the height of a falling marble is recorded and modeled by the equation y equal negative 5x plus 2. Can you tell me if this is linear or quadratic? No. Linear or quadratic? Linear. How do you know that? So you see the x doesn't have anything on top of it, so that's a degree 1. Okay? So this is linear because it's degree 1. In the table of value, I have to fill it out. Okay? So I gave you also the x values. So I gave you the x values to be 0, 1, 2, 3, and 4. Okay? So you're going to replace x with the value of x. So I'm going to replace x with a 0. Where did I get this from, the negative 5x plus 2? It's right here. Yes. It's given to me in the question. Okay? All right. So negative 5, instead of x, I'm going to replace it with a 0. So negative 5 times 0 plus 2. Bedmass tells me I have to do what first? Brackets. I have nothing inside the bracket to simplify. So I have no exponent. Do I have a multiplication? What's that? Negative 5 times a 0. What is that? That's multiplication, isn't it? Okay, so I have to do negative 5 times 0. What's negative 5 times 0? 0. Then add 2. That's going to give you 2. How about the next one? What do I do? Negative 5 times 1. So that's negative 5. Add 2. Negative 3. Negative 5 times 2 is negative 10. Add 2. Negative 8. Do you understand what's going on here? Negative 5 times 3. So that's negative 15. Add 2. Negative 13. Negative 5 times 4 is negative 20. Add 2 is negative 18. So I filled my table. Now I have to find the first difference. Okay? If I'm finding the first difference, that means I'm subtracting the lower minus the higher y value. Remember, it's y2 minus y1. So if I subtract negative 3, take away 2, what does that give me? Negative 5. Okay? You're at negative 3, you're going down 2. Then, negative 8, take away negative 3. And this is where a lot of the students mess up because they forget to include the negative 3. Okay? You're subtracting. So you have negative 8, subtract negative 3. So what happens when I have two negatives right after each other? It turns into a positive. So what's negative 8 plus 3? What is it? So you're negative 8 and then you went up 3 levels. You're at negative 8 and you went up 3 levels. Negative 5. Yeah. And then you have negative 13, take away negative 8. Again, this is another scenario where I have two negatives right after each other. So it's going to be negative 13 plus 8, which is also negative 5. And then my last one is negative 18, take away negative 13, which is again negative 5. So if you're looking at your first difference, what do you notice about your first difference? They're constant, they're the same, right? Did we expect that? Is it always going to happen that if it's linear, the first difference is going to be constant? Linear means first difference is constant, okay? So, we know it's linear because we can see that the first difference constant. Okay, now if I'm going to graph this, what am I expecting here? I'm going to go up by 2. So this is negative 2, negative 4, negative 6, negative 8, negative 10. Even if I can't fit all the points, that's okay. This is negative 12. So I'm looking at my first point. My first point is 0, 2. Okay? So my first point is 0, 2. So that means it's right here. Where's my second point? One and what? And negative 3. So 1 and negative 3 is right here. Then I have 2 and negative 8. So it's going to be about here. And then 3 and negative 13. So again, I apologize that my lines are not perfect. It's just I can't see them very clear on this.
It always goes that way if it's negative.
Yes, it goes down if your A value is negative. Okay? So it's a straight line. Did we expect that? Yes, we did, because we said from the equation it's a linear function. We have also looked at the equation. We looked at the table of value, and both of them showed me that this is going to be a linear function.